for the second part of the digital image basics, we'll talk about the indices or the index of a particular pixel. We have to know how to get a particular location of that particular pixel so that we can extract information from it and do whatever process or methods or filters that we want to do. Let's proceed. So imagine an image as a sort of a table or a grid. Okay, so for this particular example, we have 7 pixels across x-axis. But as you observe, we started with 0. We usually start with 0 because computers count starting when computers count, they start with 0 instead of our usual. We humans, we usually count as 1, 2, 3, 4, 5, but in computers we start at 0. So that's why even when in part 1 we discussed the channels from 0 to 255, but that's a total of 256 information or a range of colors. So here we start with 0. This is important because eventually in our programs, in our formulas, we need to take into consideration the 0 as a starting point. Okay? So when we talk about index, when I talk about index, it means that it's a location of a particular pixel. So in this case, we have index 0. So this is index 0, index 1, index 2, index 3 until 6. So this is from 0 to 6. If we have the height, if we have a 4 pixel height, we can assign location indices for each pixel. So as you can see, there is a total of 200. There's a total of 28 pixels. That's because 7 times 4 is 28. But the indices run from 0 to 27. So it's important that we know where to find a particular pixel. So we need their index number or their location index. So just some exercise. How do we locate given a particular the particular width and height? So it's important that we know the image's width and height in order for us to use those information when we decide where to go, where a pixel is located. So for example, at pixel 0, or the index of a particular pixel is 0. In x-axis, you can see it in 0. In y-axis, you'll see that in 0 as well. So the coordinates of pixel 0 is 0, 0. So you look at it as sort of a Cartesian plane. However, the difference is in Cartesian plane, usually when we go down in the y-axis, the values are negative. But in this one, it's positive. Okay, so that's the only difference. Anyway, so going on, pixel 1 has a coordinate of 1, 0. It means that the pixel 1 is located at the number in one pixel 1 pixel from point 0 across x-axis, but and still it's in the same row, so the the y value is still 0, so it's 1 0. If we go to pixel 6, um, the x value is 6, and then the y value is still 0. Okay. For pixel 7, since we go back to the zero location along x-axis, but we went down across along y-axis. Therefore, pixel 7 has a coordinate of 0, 1. Okay, so these are um, important information for us to learn or to get how we can go to a particular location of an image. Okay, so be mindful of the x and the y values. Okay, so um, as an exercise, if you are watching this video, you can just pause before I reveal the um, the actual answer, but so that you can have um, a practice, sort of a practice round. Okay, so for example, we want to go to pixel 9. Okay, so you know that pixel 9 is uh, this particular cell. Okay, so this particular pixel. How do how do you get the coordinates for pixel 9 given a width that is 7 pixels and a height of 4 pixels? Okay, so you can pause the video so that you can guess, um, and then we'll proceed with the answer. So the answer is 2, 1. So the coordinates for pixel 9 is 2, 1. Why is it 2, 1? Because if you see, this is 0, 1, 2. Therefore, along x-axis, it's on the um, second pixel, second location sa across x-axis. And then 1 because this is row 0 and this is row 1. Okay, so think of it as columns and rows. 0, 1, 2. Therefore, x is 2. And then 0, 1. This is 1. So pixel 9 is located at the coordinates 2, 1. Next, how about pixel 18? Okay, so you can pause the video again so that you can guess it before I reveal the answer. So the answer is 4, 2. Pixel 18 is located at coordinates 4, 2. Looking at this as a table again, we can find that this is 0, 1, 2, 3, 4. This is the fourth. This is column 4. But remember, we started at 0. So this is column 4, and this is 0, 1, 2. This is called row 2. Therefore, the coordinates is 4, 2. And how about pixel 22? So using the same method that we use, we can think of it as columns and rows and assign a particular number. For example, this is column 0, column 1. So pixel 22 is along column 1, But in terms of row, it's 0, 1, 2, 3. So that's pixel 22 is located at coordinates 1, 3. Okay, so I hope you have you understood the process when locating a particular pixel. Later, we'll discuss a particular formula for that one. Okay, but we do the reverse. So in the previous examples, I provided the pixel index and we guessed the coordinates for that particular index. So we do the reverse. What if we know the coordinates and we want to know the index of that particular coordinate? Okay, so how about this one? We know that the coordinates is 2, 3, but we do not know the pixel index. So the number you can see here in the grid are the indices. So 2x is on column 2, 0, 1, 2. It's around here. It's either 2, 9, 16, or 23. And the row is 3. So 0, 1, 2, 3. So the pixel is 23. Or the index is 23. Okay, so you can do the same. You can pause the video and try to guess or try to formulate a particular method or a process wherein you'll find the answer in a systematic way. Okay, so for example, we have 6 for x and 1 for y. Which particular pixel is this? So the answer is pixel 13. So we see that pixel 13 is on uh, uh, column 6 and then row 1. How about 5, 2? So you can pause again and then try to guess or use your process in order to find the index. The answer is pixel 19. Okay, so it's on column 5 and row 2. Okay. So how did you process the information given to guess the location or the index? If you are given a coordinates, um, how do you come up with the index? Okay. So going back to the last the latest example, we were given 5, 2, and we reached the decision that the that's pixel 19. Okay. Of course, we can do this we can do this manually given a small image. For example, this is a 7 by 4 image only. So we can do this manually. But as you know, images are having resolutions such as 1024 by 768 and 2048 by 1280. So these are large images, and then there at some point there are thousands or hundreds of thousands of pixels in a given image. So we can't possibly, well, we can, but that will take a very long time to process, to get the information for each pixel. So we need some sort of a formula, that we can use in any programming language um, that you want, that it's convenient for you, and then to create a program for this one. Okay, so how do we get, given this, what do we have as information? We have height, we have width, we have x, and then the value of y. How do we go, how do we arrive at the answer index 19? So if you already have some sort of a process, then you'll probably get into this kind of formula. Okay, so index is equal to width, the quantity width times y plus x. Okay, so to check if the formula is correct, so we substitute the values. The width is 7 pixels. Uh, y is given as 2, and then x is 5. So 7 times 2 is 14 plus 5, that's 19. So we check for all the um, examples that we used earlier. Okay, for pixel 13, we were given as the coordinate 6, 1. So we try to substitute the values in the formula. So width is still 7 because we're talking about the same image that is 7 by 4. So 7 times 1 is 7 plus 6, that's 13. So this is how we get into the particular index given the coordinates. Okay, so these are some examples. We can just pause and then try to analyze the formula. Okay, so this is for pixel 9. So that's for the second part of this session. Okay, so we talked about um, going into a particular location, um, creating a formula that that we can use every time we are asked to locate a particular index given the coordinates. Okay. So in part 3, what we will be doing, since we already know how to go into a particular index to a particular coordinate um, of the image, we can already, what we want to do is to get the information, to extract the red, the green, and the blue values. Okay, so let's go to part 3.